Good night, Dorian. Thank you for being always on time. I really appreciate this detail.
Good night. No worry.
I really take it in count because, well, we said 9 and you are the only one student that I get on time. It's important to get this habit, especially in our career. Thank you so much.
Yeah,
You are a student
yeah.
at this point.
Okay. Just used to that. Yep.
Yes, that's the best way to be for life. I tell you by experience. When I was at med school,
Mhm.
if I, as a student, get or arrived late at the class, the professor didn't let me get into, and the reason was simple. All professors told me, "You are late. Your patient is dead. Goodbye," and they then closed the door in my face. It was so funny at the beginning, but then you are realizing that, well, that's the truth. Sometimes because we arrive late, we lost the chance to make our job properly, and that's right. That's the point.
Yeah, totally agree. Yeah, it happens to me all the time, especially at university. So we always gotta be on time.
Um, okay, so let's wait a little bit. I think because, well, good night, Diana. Thank you for being for getting into so early, almost on time.
Hi,
So
Miss. How are you?
fine. Well, a very busy day, but it's possible to continue. Yeah. Thank you for helping me starting an hour later. I really appreciate this. But well, let's wait for your classmates, okay? I think could be until 9 and 10.
Yeah, it's okay. No worry.
Okay, is that okay for you, Dorian? 9 and 10? 8 minutes more?
Yeah, I think so.
Okay, perfect. Thank you so much. So let's wait some minutes more and then we can start. No matter if we are just just us, okay? 9 and
Okay.
10. I'll be back. Okay, everybody, let me see. Can you watch my screen? Hi,
Yes.
can you hear me?
Yes.
Okay, great. Thank you. Well, tonight we have a presentation with lots of vocabulary that we must take in count, because it's a specific vocabulary while talking about statistics and talking about specific ways to show data. I mean, to show that the information that is supporting investigation or charts or detail like that. Okay, we are going to see how to express this kind of ideas. So let's start. It's not very long, but it takes lots of vocabulary. We are going to check research studies, presentations, data presentations in different situations, okay? Research as a concept, as an idea, we must consider this term. In a general view, research is the systematic investigation into and study of materials and sources in order to establish facts and reach new conclusions. No matter the branch, when you prepare a research, you make this kind of job, you're making an investigation, of course. You use material, you use some sources, and according to that, you can establish facts, you can support facts, and according to that, you can support previous conclusions, and you can show that they are working the same way, or maybe you are just finding a new conclusion. According to your objectives, you got these facts, okay, these conclusions. In medicine, research and health disciplines conducted using scientific methods with the aim of acquiring new knowledge about health and disease. We all know about it. Medical research always is looking for solutions about health problems, always looking for that way to help in a properly way our patients, or maybe trying to support again some protocols, some rules into our career in order to try to make them easier and work properly and faster. Research studies, well, a scientific study of nature that sometimes includes processes evolved in health and disease. That's the meaning of this term, research studies. These scientific studies, of course, follow a process. We all know the scientific methods from high school, from primary school too, and we got that idea. And if we look for this process during our career, we can realize that everything we develop, every patient we treat on, we got into this scientific method, and well, that's possible to make it in the way it works. For example, clinical trials are research studies that involve people, of course. Studying may be related to new ways to screen, prevent, diagnose, and treat disease. Same way we are talking now, of course. Let's check our first definition, the case control studies. The case control studies is that a study that compares two groups of people. One group with a disease or condition under study, the group of cases, and a very similar group of people who don't have the disease or condition. They are the control. Could be people with diabetes, people without diabetes, but that have similar, the rest of the parameters to evaluate are similar. The only difference is the diagnosis of diabetes, okay? In this chart in gray with the black eye, we are going to catch some vocabulary in black and words. They are for supporting the definition I sent you, and they are also making the comparison, giving a small explanation. So read this carefully, because here you are going to find some expressions and some vocabulary that is so helpful, okay? In a case control study, a group of people is suffering from a disease. Is compared with a group of who don't have the disease, but are similar in other ways. Okay, same idea. The two groups, the participants in the study, are compared to see if they were exposed to a possible risk factor or not. Of course, we know a risk factor is something which may contribute to cause of disease. This type of study is often used as a first step in identifying the causes of a disease. I mean, we got our two groups, we make the similar situations, we get the differences, and then we decide which situation is going to be the control. And according to that, we decide. We're identifying what kind of situations are appearing in order to develop the pathological situation, the disease, okay? For example, we got people that are exposed and are unexposed. And we got the cases in past. In the case control, well, we got the period of time, we got the onset of the study, and if we make the comparison between them and them, we can decide which ones of this group of the controls developed from the first group, developed the situation if they were exposed or not, according to the situation we are studying. Could be with this example. In a case control study, we can get a population, a group of people from 20 to 30 years, male and female, with no other risk factors than smoking in the place of job. During a period of time, we compare two groups that are similar, same number with men and women, same ages, of course, same kind of life, over a similar kind of life, and we can prepare the exposition they are going to receive from smoking, specifically cigarettes and pipes. According to that, with that period of time, we can realize in that control how many people of this case controls get with lung cancer or a pulmonary disease in order to identify the specific risk factors that can show us how to develop this disease. I'm not sure if it's possible to catch at this point, but that's the idea. Case controls always takes a period of time. They are usually long, maybe according to the situation, could be from 5 years, 10 years, 20 years. It's according to the situation you are studying. That's why they really need to be similar in the kind of life, similar in age, similar in weight, in habits and things like that, and similar in the time or period of exposition to the pathological situation to develop the consequence, to develop the disease. On the other hand, we got cohort studies. The cohort study is a research study that compares a particular outcome, again, lung cancer, in groups of individuals who are alike in many ways but differ by certain characteristics. For example, female nurses who smoke compared with those who don't smoke, okay? We got these two groups and it's easier to make. Again, we got this gray chart, and we got this, a cohort study, a cohort group of people, of subjects who are similar or studied over a period of years is a longitudinal study. We got this period of years, and we compare the moment of the onset and the moment of the cohort. Not all the years, just that 2 periods. That's longitudinal. It's a period of time to determine if the relationship are between exposure to a risk factor and development of a disease. At the beginning of a prospective study, none of the subjects has the disease. All of them are healthy. They are followed up for a number of years. At the end of the period, those who have developed the disease are compared with those who have not. In a retrospective study, the researchers look back. I mean, we get into the past. We can go to, we can study hospital records, for example. We can study clinical histories by particular period of studies, by a particular research. And well, we can check in the past by reports, by oral reports, all the information. We can collect all the information from that reports, and then we can compare the subjects who have developed or not the disease with those who haven't. In a cohort study and in a case control study, subjects are only observed and there is non-intervention. We as researchers don't have to do anything for avoiding any kind of situation during this period of studies. We have to be clear on this. If we make an intervention, all the research is dead, is spoiled, okay? A cohort study is a more reliable method to identify the cause of disease than in a case control study. But for proof causes, a trial is needed. Always trials are important. Okay, please give me a second. I have a detail with my... Okay, I'm back. I'm sorry. I have a little problem with the slides. I don't know what I pushed. Let me share again the screen. And tell me, Diana, I can see your hand is raised.
No, I was about to say that I couldn't hear anything, but I know that why now.
Yeah, I'm sorry. I don't know what I did with my keyboard, but I closed the presentation. But no, it's here again. So I'm sorry. Okay, a trial. When we make trials, we have to be clear on this. This type of research tests how well a new medical approaches work in people. I mean, just focusing into our branch in medicine, we know that everything is coming from trials. Everything, medication, treatments, ways to evaluate that, ways to make the physical exam, protocols, everything has trials. And of course, when we develop this kind of research, we must be clear that in trials, we need population that has to be studied, people that has to get into this kind of studies. These studies test new methods of screening, prevention, diagnosis, treatment of a disease, well, anything according to our career. In trials, we usually look for volunteers, or we look for specific situations and cases that, according to the informed consent, we can get the permission of the patient to take him as a trial, as a number into the trials and the statistics to decide if this research or if this new method or anything is possible to apply, right? Let's read this chart. In a trial, a group of people who are suffering from a disease are given a particular treatment to determine the effectiveness of the treatment. A controlled trial is performed. I mean, the controlled trial is when we got the group, we got our volunteers with all the documentation that is clear that they know that they are going to be into a trial, and we give them new medication, for example, the COVID-19 vaccine. We apply the vaccine and we study that patient that volunteer for a period of time, and we make controls. That's a control trial because we are taking in account all the possible consequences from that medication. Okay. 2 groups are studied. One group is the study group, the group that is receiving the medication, and the control group, a group of people, volunteers that are not receiving the medication. They receive a placebo, something that looks identical to the medication, but it has no effect, okay? And there is an equal possibility that patients could be selected for the study group or to the control group. They don't know if they are into the study or the control group. They know that they are volunteers, they know that they are going to receive medication, and that's all. But they don't have to know if they are going to be as a study or as a control, okay? That's very important in this part. If there is an equal possibility that patients may be selected for the study group of the controls, the trial is set randomized. Okay? A randomized control trial make bias. Bias are errors in a study which influences the results. These biases are very common according to the situation you are studying. We can support this, for example, the easiest example, the COVID-19 vaccine that was applied in Argentina got a group of people, imagine that 1,000 of volunteers. They get the study and the control, the study group and the control group, and they didn't know which one was which one was receiving the vaccine or the placebo. Okay, until this point we are clear. When taking the results, some people with the placebo was thinking that they received the vaccine and was developing the probable side effects of the vaccine. That's a bias. That's an error because they are not receiving this. They are just imagining the symptoms and they are suffering things that are not real. They are I forgot the term, but in Spanish it's somatizando. They are feeling in the body the symptoms, or they are showing findings that are not at the moment the ones that are expected with the vaccine. I don't know if it's possible to catch the idea. Well, an additional way of removing bias is blinding. When we say blinding, it's patients that they don't know if they are receiving the treatment or the placebo. Until this point, we are clear. Patients don't have to know about it. But researchers, they don't have to know which one is receiving the treatment, okay? Simple blinding, when patients have no idea which thing they are receiving. That's the most common way to make this kind of a study, of trial. A double blinding trial is when researchers also don't know. Just the chief maybe that, for example, you need to apply the COVID-19 vaccine, you go to your boss and the boss gives you the shot ready for applying. You don't know if it's medication or if it's just a placebo, right? Randomized control trials are used to test treatments or preventative measures. We know about it. We were living on this. A vaccine trial takes around 10 years, not 10 months, 10 years. That's the way it should work, because we have to study all the side effects that are new at the moment. We have to study all the consequences in a long period of time. For children, for elderly as well, in different stages in life, in different situations, with different pathologies, but well, sometimes it's not possible to make it. But that's the way it should be. Well, that's just a joke, I like it. Well, of course, he's still in a clinical trials. He's still being in a clinical trial, but he looks very promising. When medication looks promising, means that has lots of good results at the moment with not extra side effects, not so harmful side effects. That's why that's important to understand that very promising. It's promising medication. That means that works properly against bugs, but instead of getting a resistance so high or so fast, they are easy to stand for the patient. They have no too much consequences, not too much side effects, no allergies, of course. Well, let's check variables. A variable is an inconstant data which can or does change as contrasted with a constant. I mean, you have, well, we are going to check a chart of this. The deviation from the type in structure, form, physiology, or behavior. I mean, all the characteristic that subject, that our patient to be coming to this kind of studies or research, all the characteristics, the specific characteristics it has are variables. Could be age, sex, gender, occupation, weight, you know, many things. If the subjects in the study are all aged 50, the age is a constant in the study. Why a constant? Because ages range, or because constant, just 50, is a variable that it's not going to change. That's why it's constant. If their ages range are from 20 to 70, for example, the age is variable because you have all of this range from 20 to 70 to catch information, to place the subjects, and then you know that it's not going to be just one value. That's why it's variable. A confounding variable is any variable which is associated with both the disease and the risk factor being studied. For example, smoking in the case of cooks and lung cancer. You know, the previous one we were discussing in the previous presentation, right? If such variables exist, there is no way for the researcher to know whether the difference in the risk factor or confounding variable is the one that is truly causing the disease. I mean, if you have a big range of variables, you have lots of situations to consider. At the moment to organize information and take conclusions, well, it's not possible to take the correct the correct variable that is causing the consequence. That's the confounding, to the mixing variable, okay? At this point, we got this. The types of variables could be independent, could be dependent, and can be controlled. The independent variable, one thing that you change. You decide how it works. Limit the only one in an experiment. For example, in this case, the liquid used to water each plant. You can use anything, soda, water, juice, I don't know, soap, anything. It's an independent variable. Just one thing you can change. The dependent variable is the change that happens because of the independent variable. I mean, according to the liquid the plant is receiving, how high it's gonna get, okay? The height or health of the plant according to the liquid is receiving. And the controlled variable, everything you want to remain constant and unchanging. So, I mean, situations that you are not going to change because it's not possible to do it. I mean, type of plant used, checked. Pot used, checked. Amount of liquid, great. Soil type, okay. Height you are expecting for. They are variables that you are not going to change for any reason. That's a controlled variable. According to all the situations that are evolving, all the research, it's possible to make, in my opinion, a better research because you got all the possibilities organized. They are all set on the table and it's possible to check clearly which variable could infer into the result. The controlled is has more possibilities to be trustable, the dependent or independent, of course. Well, while talking about data presentation, it's a very interesting topic in my opinion. Because all the time during med school, we have the chance to read information with this kind of charts. All the time, statistics are supporting our career. Statistics give us the chance to organize information, to understand that information, and to show and teach from that information, right? Data presentation is defined as the process of using various graphical formats to visually represent the relationship between two or more data sets so that an informed decision can be made based on them. When we evaluate patients, critical patients, following scores, for example, Apache scores or QSOFA scores, all of this information, all of these scores are coming from research and coming from this kind of information that we get into statistics, and then we can decide how to punctualize, how to give a score and specific number to all the parameters we get, okay? When we talk about referring to a table or a figure, it's a very general situation when we have to consider this structure always. If you don't find all of this information, it's not the correct information you are catching. You need the number of the table or figure, the title of this. The title is giving us in a sentence the abbreviations meanings, as you can see. You have to find if it's necessary, you have to find the source it's coming from. Into the table in this case, you got the study, which groups of researchers made it, and which year this study was developed. The variables, of course, you're checking, and the results. Following the results, you can get conclusions at this point in this kind of chart. Sometimes just come with the study, the group, or the first variable, second variable, third, fourth, fifth, no matter, just okay. In an article, you can write, you can give me this information. Figure 1, table 1 shows, and then give me the result. Like this study reported factor level associated with the for example. The result of the is according. Okay. Okay, again, in a presentation, you can use this expression. As you can see in table 1, in figure 1, in the previous chart, anything, you can start introducing. This is the expression that is giving the detail that you are showing this information properly. When we compare variables, we got specific terms that we have to use, specific words that we can show. We will often need to compare a variable with another, and the expressions are this. X was twice as effective as Y, for example. Or could be X was 3 times as effective or as common as Y, or as effective as Y, or things like that, okay? The specific words, twice, 3 times, 4 times, and as, per, as, right? From Common English. We make these number comparisons or use these expressions that showing values because that's the way that variables usually work. For example, we have more expressions that show this kind of information, okay, at the same time. For example, the number of X in 2000 was double than that in 1919, right? The number of X in 2000 was triple or 3 times that in 1990, right? Double, triple, or double 3 times is for comparing values. We know it's similar to Spanish, or we can get another way to give the same information. There was a 2-fold increase in the number of X between 1990 and 2000. I mean, there was 2-fold, or there was 2 times fold, 2-fold increase the number. There was 3-fold increase in the number of, right? 2-fold, 3-fold, 4-fold, well, according to the situation, right? The number of X increased 2-fold or 3-fold between 1990 and 2000. The number of X doubled or tripled between 1990 and 2000. I mean, we are showing how these values are getting higher 2 times, 3 times, 4 times, and expressions 2 times 2-fold, 3 times 3-fold, okay, 3-fold. Doubled, for example, in this class, we got, I don't know, 10 students. In the next group, we expect to have doubled students, okay? I mean, the idea, I hope it's possible to catch. When we use approximating, I mean, we have to find a way to give a specific speech that is going to be interesting for the rest of the people, for the audience. And of course, during presentations in slides, when we give data, all numbers should be rounded. Usually, they are rounded. For example, 41.3 becomes 41 or even 40. We change this kind of value in order to make the speech easier, to make the speech rounded, make it interesting and not so plenty, not so boring. When this rounding is done, it's common to use expressions of approximation. All of them are this in the middle in black and about, around, approximately, roughly, or some. For example, side effects were reported by around 40 patients. Side effects were reported by roughly 40 patients. You can see, I'm not giving specifically the number, 41.3, for example. I'm giving around 40, could be 40. While reading, while checking the slides, it's possible to check that the value is there and my speech is easily to catch the information is shown, okay? Common in medicine, even when the exact number is given. For example, roughly 2 or 55 or some 2/3 of patients reported side effects. Here we are giving the values without giving numbers, but we are showing the idea that 2/3 or 50-50, we catch the meanings of this, right? When you want to emphasize a number, for example, 9.8%, you can say almost, nearly, more than, over, or just under. You don't give the number exactly. You give similar numbers for catching the attention, for making it easier, and while reading, checking the number, and while making the review, reminding the speech, you catch easily this value or maybe this value, but you are so close to the answer, right? And when you want to make numbers seem small, always less than, perfect, less than 10% of patients or something like that. We can continue, right? That's the way it works. And while during the speech, it's very common to catch this. Checking some graphs, we can see this, a line graph. Very common, always check during our careers, right? Also known as a line chart, or a line plot, is commonly drawn to show information that changes over time. I mean, we have the number of boxes, we have the period of time, is picking up, reaching a peak, right? You can plot it by using several points linked by straight lines, like this picture, and it compresses two axes called the X and Y. We all know about it from high school, right? Notice the verbs that can change over a period of time. I mean, following how the information is moving, right? You can say rise, increase, go up. When the information goes down, you can say fall, drop, decrease, go down. Or they can reach a peak. They reached a peak and they started falling down. Okay. Or they remain the same. This difference is important. When they go high so fast, rise sharply, steeply, rapidly. Okay. Or if they took a period of time, look at this is one, this is second direction, this is the third one. Rise steadily, rise gradually. Okay. In this slide with the blue guy, we got the most common verbs, the most common ones. But of course, we have some more. The pie charts are a type of graph in which a circle is divided into sectors. We all know about it. A pie with slices, okay? The whole. Pie charts are a very effective way to show a relationship of parts to a whole. We can realize just by watching the colors how it's done, which one is bigger, which one is smaller, and then we get an idea how it's working on. Instead of numbers, it's easier to check pictures, right? Again, another example showing the same. You can compare, for example, in this case, a smartphone and tablets, and just while watching without checking the numbers, you know that this is smaller than this, or this is smaller, of course, than this. These differences is helping us for making our presentation most interesting, easiest, okay? About trends, of course. Again, a very common graph we check during medical information. A trend is the general direction in which something is developing or changing over time. Again, we have a period of time to study this. A projection is a prediction of future change. Trends and projections are usually illustrated using the line graphs, in which the horizontal axis represents time. This is the time. Well, this is an extra slide with the blue guy for showing you more verbs, giving you the direction of the trends, extra information just. Now we got some verbs and the word order for giving the correct expression while talking about trends. For example, in sales, is the subject, the verb fell, and the adverb slightly. The verb, what happened? They fell. How did it change? Slightly. Prices dropped sharply. Production rose steadily. The percent of X decreased significantly. The number of X increased dramatically. You can check. All of these verbs are always in past. Always, always, always. Never in present, because you are given information that is already studied, that is already prepared. Okay? You are not receiving the information, making the chart, and giving the detail at the moment. No, it's not possible to make it. It doesn't work in that way. It's the same as in the case report. You prepare your information, prepare your paragraph, and when everything is done, you show the case report. It's the same. When you got all the information prepared, you give me the information in past. Another way could be there, verb, a, and the adjective or noun. There is a slight rise in sales. There was a gradual fall in the price of X, right? There has been a dramatic drop in the rate. Okay. There will be a steady decline in the number. You got this, okay? When you got the adjective and the noun, well, there's the grammar formula to make it properly, for not mixing the place of the noun and adjective. That is very common. Don't worry about it, just grammar detail. When we talk about this kind of descriptions, we consider prepositions. Of course, prepositions to compare how this information is getting high, getting down, well, I don't know. For example, a very easy description, a simple one could say, it decreases from 10 to 4, okay? There was a drop of 6 units, or 6 just. Or you could say, it dropped by 6, okay? A decrease in the number of blah, blah, okay? In the number of between 2010, because you have the period of time in X, and to time out for to 2014, okay? Or a decrease in the number of between a decrease in the number of between 2010 and 2014, or from 2010 to 2014. Okay, these prepositions are very common during social English. In medical English, of course, we use the same. While talking about another way to do it, we can say, it started at 4, it peaked, or it reached a peak at 10 units, it dropped by 8 units, you know, fall down 8 units, the lowest point, at 2 points, at 2 units. Then it increased to 6. Okay, you can see it's in 6. And it remained stable between 2010 and 2012. It finishes at 6 in 2012. You can see, we can describe how this line is going on, not having any trouble, just using prepositions and checking the numbers, okay? Then we got, it's just an example, but let's see. As a noun, a peak. As a verb, to reach a peak. This is the expression, reach a peak, okay? As a noun, a plateau. As a verb, to reach a plateau. Another way to say it, to remain the same, okay? This is a fluctuation. As a noun, fluctuation. As a verb, to fluctuate. This one. Noun is a dip. Verb, to dip. Okay, and this point. It is its lowest point or its lowest amount as a noun. As a verb, we can say to fall to its lowest point or to hit its lowest point. You can notice here two ways to give the same information into different expressions, right? As a noun or as a verb. Take place doesn't count while making the speech, while filling homework file, or even the final test. Well, that's an exercise, but just an example. Don't worry about this slide. I'm not going to take it in count. Okay. The bar chart below shows the prevalence of HIV in different countries. You can see lots of countries and values, people that is infected at the moment. Here we got some blackened words to catch the vocabulary properly. And we can say HIV rates have fallen in some countries as a result of safer sex, but the overall trend is an increase in HIV infections. We all know about it. The steepest increases in HIV infections occurred in the Eastern Europe, Central Asia, and East Asia, but Sub-Saharan Africa continues to be the most affected part of the world. Adult infection rates in Kenya have dropped from a peak of 10% in the late 90s to 7% in 2003. HIV rates in pregnant women in Zimbabwe also fell over the past 2 years. Okay, just checking values, we can catch all of these meanings, right? We're practicing, check this, read this paragraph, and check if it's properly done, properly said, okay? And, you know, never give up. As John Cena says, never give up. We are still working on this course. You're doing great. Thank you for continuing. Thank you for taking it in account. I'm practicing too much. Well, that's all for today. Let me send you the poll to take attendance, and I'm gonna set the slides in the Zoom chat in a second, please. Okay, the presentation is uploading to the chat. But now let me give you some information. At this point, well, we have this week classes, and the next week is going to be the final test of Module 2. We are on time. We all know about it. Next Thursday it's going to be. Please start reading, start checking the information. If there are questions, please let me know by messages to my WhatsApp. There's no trouble on this. I sent you all these details for you for practicing. Usually I don't send this information just to my students. Please read all of this, practice on this. Any question, an open mind to give the ideas that you certainly need. If something is not clear, let me know via message and we can correct it, okay? I know that at this point, I owe you writing exercise. I mean, a new clinical situation for preparing the case report and the physical exam and the readings with lab tests and imaging tests. Actually, at this point, I couldn't send the clinical case for all the situations I had at the weekend. But tomorrow during the workshop, we are going to work together in this point, in this fact, okay? In that way, tomorrow we are going to prepare the report of the lab reports on the imaging reports in the clinical history in order to organize ideas properly. And on Thursday, I'm gonna receive the homework files. So that's the reason why I didn't send the writing exercise of this weekend. Then at this point, I think we have to be clear on this. Final test is coming again. You know, the score for approval, the test is 51, but you can do it better, of course. Try to reach the best score. And that's all at this point. Let me know by a message to the chat if you go to the slides, if it's possible to open them. And well, we can work on this, okay? Any question until this point? If there is nothing to continue, or if you couldn't fill the pool, let me know by a message, please. And well, if you got the slides and fill the pool, that's all, and let's meet tomorrow, okay? Okay, Laura and Diana, thank you. Great.
Dr. Iris,
Yes.
can you send me the slides inbox, please?
Of course, Jimena, there's no trouble on this. I'm gonna do that. Jimena, did you fill the pool?
Yeah, I got it.
Great, perfect.
Thank you very much.
Thank you, Dorian. Thank you, Andrea. Thank you. Okay, Sarah. Elena, did you fill the pool? Did you have the chance to do it?
Yes, I did it.
Okay, great, because there is someone who didn't fill it, but it doesn't matter. Okay, great. Elena, did you have the chance to fill the pool?
Yes, I sent it.
Okay, great. That's correct. There's no trouble on this. No, don't worry. Tomorrow we are going to work on your specific exercise, Jimena and Jacqueline, okay? So don't worry, I decided not to send the
Okay,
right
teacher.
exercise. I couldn't exchange the details in the way I need to do it, okay?
Okay, teacher. And don't forget to send us, please, the
Yes, yes.
material today inbox, please.
Inbox. Yes, you vote. Don't worry about it. I'm gonna do it.
Thank you, teacher. Thank you so much.
Okay, you're welcome. See ya.
Bye, teacher. Bye-bye.
Goodbye. Bye-bye. Have a great night. See you tomorrow.
Thank you.
See you tomorrow. Bye, Dr. Iris.
Bye, Jimena. See ya. Have a great night.
Thank you very much.
Okay, everything is said, everything is done. So I think I can close this. So good night.